Installing an electrical load center in a stairwell presents a complex issue with both potential benefits and significant safety concerns. Accessibility is a key reason cited for such installations. Stairwells often provide relatively easy access for maintenance and troubleshooting, particularly in emergency situations. The centralization of power distribution is another factor. Placing a load center in a stairwell allows for the distribution of electrical power to multiple areas of a building from a single, central location. In some cases, space constraints within the building may lead to the stairwell being considered as a suitable location, especially in mid-rise buildings where stairwells might offer more available space compared to other areas. Code compliance can also play a role. Some jurisdictions may require electrical load centers to be installed in common areas that are readily accessible to all occupants of the building. However, these potential advantages must be carefully weighed against the inherent safety risks. Fire hazards are a primary concern. Electrical load centers, by their nature, involve electrical connections and components that can generate heat and potentially sparks. If a fault occurs, the load center could become a source of ignition, posing a significant fire risk, especially in a stairwell which serves as a critical evacuation route. Access during an emergency is another critical consideration. A load center located in a stairwell could obstruct or hinder evacuation efforts in the event of a fire or other emergency. Firefighters might also face difficulties in accessing the building or navigating the stairwell if a load center is in the way. Trip and fall hazards are also a potential issue. The cables and wires associated with the load center could create tripping hazards for occupants using the stairwell, especially in low light conditions or during an emergency evacuation. Electrocution hazards are also present. Improperly installed or poorly maintained load centers can pose a risk of electric shock to building occupants who may come into contact with exposed or damaged components. Opinions on the safety of installing electrical load centers in stairwells are often divided. Some electricians and building managers may argue that such installations are perfectly safe, provided that they are carried out and maintained in strict accordance with all applicable electrical codes and regulations. Others may express serious reservations, citing the potential fire hazards and the risk of obstructed access during an emergency. Given these concerns, it is essential to adhere to best practices to mitigate the risks associated with installing a load center in a stairwell. Firstly, compliance with all relevant electrical codes and regulations is paramount. This ensures that the installation is performed correctly, using appropriate materials and techniques, and that ongoing maintenance is carried out to maintain safety standards. Secondly, the use of fire-rated materials is crucial. The load center should be enclosed in a fire-rated cabinet or junction box that is designed to contain a fire and prevent it from spreading to the surrounding area. Thirdly, the installation of smoke detectors and sprinklers in a stairwell can provide an early warning of a fire and help to suppress it before it can escalate. These devices should be properly installed and maintained to ensure their effectiveness. Fourthly, it is essential to provide clear access to and around the load center. The areas should be kept free of obstacles that could impede access or create a tripping hazard. This is particularly important during an emergency evacuation. Fifthly, regular inspections and maintenance by a qualified electrician are essential. This helps to ensure that the load center is operating safely and efficiently, and that any potential problems are identified and addressed promptly. A National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and maintenance of electrical equipment, including load centers. Several articles within the NEC are particularly relevant to installations in stairwells. NEC Article 110.3 B covers examination, identification, installation, and use of equipment, emphasizing that equipment must be installed and used according to its listing and labeling. NEC Article 240 addresses overcurrent protection, requiring that load centers be protected by circuit breakers or fuses to prevent overloads and short circuits. NEC Article 312 covers cabinets, cutout boxes, and meter socket enclosures, specifying requirements for their construction, installation, and accessibility. NEC Article 408 pertains to switchboards, switchgear, and panel boards, providing detailed requirements for their installation and wiring. Specifically, Section 408.3 requires sufficient working space around electrical equipment for safe operation and maintenance. NEC Article 450 addresses transformers, which may be associated with load centers in some installations. It includes requirements for transformer installation, ventilation, and protection. In addition to these general requirements, local building codes and regulations may impose additional restrictions on the installation of electrical equipment in stairwells. It is essential to consult with local authorities to ensure compliance with all applicable requirements. Several specific safety measures can be implemented to further reduce the risks associated with installing a load center in a stairwell. These include using arc fault circuit interrupters, or RSIs, to protect circuits against arc faults, which are a common cause of electrical fires. Installing ground fault circuit interrupters, or GFCIs, to protect against ground faults, which can cause electric shock. Ensuring that all wiring is properly insulated and protected from physical damage. Providing adequate ventilation to prevent overheating of the load center. Regularly inspecting the load center for signs of damage or wear and tear. Maintaining a clear emergency evacuation plan that takes into account the location of the load center. The decision of whether to install an electrical load center in a stairwell should be made on a case-by-case basis, taking into account all relevant factors, including building codes, safety regulations, and the specific characteristics of the stairwell. A thorough risk assessment should be conducted to identify potential hazards and evaluate the effectiveness of mitigation measures. It is also important to consult with qualified electrical engineers and safety professionals to ensure that the installation is safe and compliant with all applicable requirements. Consider the following points when assessing the suitability of a stairwell for a load center installation. The width and height of the stairwell, ensuring that the load center does not obstruct the means of egress. The fire rating of the stairwell enclosure, ensuring that it is adequate to contain a fire. The availability of ventilation, ensuring that the load center does not overheat. The presence of other utilities in the stairwell such as plumbing or HVAC systems, ensuring that they do not interfere with the load center. The potential for vandalism or tampering, ensuring that the load center is adequately protected. The accessibility of the load center for maintenance and repairs, ensuring that qualified personnel can safely access it. The impact of the load center on the aesthetics of the stairwell, ensuring that it is visually unobtrusive. Let's consider some example scenarios to illustrate the decision-making process. In a high-rise office building, a stairwell may be the only feasible location for a new load center due to space constraint. However, the stairwell is narrow and heavily used, posing a significant obstruction hazard. In this case, the installation of the load center would likely be prohibited due to safety concerns. In a low-rise apartment building, a stairwell may have ample space and be well ventilated. The building is equipped with a comprehensive fire suppression system. In this case, the installation of the load center may be permissible, provided that all applicable codes and regulations are met. In a historical building, a stairwell may have unique architectural features that would be damaged by the installation of a load center. The building may also be subject to historical preservation regulations. In this case, alternative locations for the load center should be explored to avoid damaging the historical fabric of the building. It is important to remember that the decision of whether to install an electrical load center in a stairwell is not solely based on technical considerations. Social and ethical factors also play a role. For example, building owners and managers have a responsibility to protect the safety of their tenants and employees. They should not prioritize cost savings or convenience over safety. Furthermore, building occupants have a right to be informed about potential hazards in their environment. They should be consulted about the installation of a load center in a stairwell, and their concerns should be addressed. Consider the specific electrical calculations that might influence a load center installation. First, determine the total load. Calculate the total electrical load that the load center will be required to serve. This involves adding up the wattage of all the connected appliances, equipment, and lighting fixtures. Second, calculate the feeder size. Determine the appropriate size of the feeder conductors that will supply power to the load center. This calculation is based on the total load and the allowable ampacity of the conductors, as specified in the NEC. NEC Table 310.16 provides ampacity ratings for various types of conductors based on their size and insulation. Third, calculate the overcurrent protection. Select the appropriate size of the overcurrent protection device, such as a circuit breaker or fuse, to protect the feeder conductors and the load center. The overcurrent protection device should be sized no larger than the ampacity of the feeder conductors. Fourth, calculate the grounding requirements. Determine the appropriate size and type of grounding conductors to ensure that the load center is properly grounded. Grounding is essential for safety as it provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electric shock. Fifth, voltage drop calculations. Perform voltage drop calculations to ensure that the voltage at the load center is within acceptable limits. Excessive voltage drop can cause equipment to malfunction and can also reduce energy efficiency. NEC Informational Note Number 2 to Section 210.19. 8.1 provides guidance on voltage drop. In summary, installing an electrical load center in the stairwell is a complex decision that requires careful consideration of both potential benefits and significant safety concerns. By adhering to best practices, complying with all applicable codes and regulations, and conducting a thorough risk assessment, it is possible to mitigate the risks associated with such installations and ensure the safety of building occupants.